Hello and welcome, everyone. It's a pleasure to be here. And we will be talking today about Apache Iceberg with Unity Catalog and how we are leveraging that at HelloFresh. Before we dive into that, just very show of hands, how many of you are actually using HelloFresh? Okay, cool. That's nice. Glad to hear that. I hope it's going to be more in the future, of course, once you learn what an amazing architecture we have here up and running. But let me quickly show you what we have actually prepared for you here for today. So at the beginning, we will be talking a little bit about data engineering at HelloFresh in general, how our architecture looks like, what was our starting point on the journey towards Iceberg and Unity. We will dive a bit into the decision of why we started using Iceberg specifically at HelloFresh. And then I will be handing it over to my colleague Adam, who will be talking about Unity Catalog for Iceberg and specifically. So really diving into the technical details of that and also of the catalog federation aspects that we have with that. Before we do that, a quick word about myself. I'm Max. I'm the guy in yellow. I'm the director of data engineering for the data platform of HelloFresh. So I'm leading all the areas related to the underlying data infrastructure, as well as the productivity layers that we have on top of that. I've been very actively working on productionizing large-scale data, both infrastructure and data management platforms over the past couple of years. I've got the chance to speak here at the summit already a couple of times in the past. They're mostly focused on aspects around data mesh. And that's also where I'm still very actively involved with. Adam, do you want to say a couple words about yourself?
Sure. Hello, everyone. My name is Adam. I am senior staff data engineer at HelloFresh, linked with HelloFresh for about 4 years now. I build and help our internal teams to expand data platform offerings for internal users, customers. And I am quite passionate of making the complicated challenges easy for the end users. And I started my career as a backend engineer, front-end engineers, and I decided to spice up the challenges, and I moved into the data world a couple of years ago. Thanks.
Just a couple of words about HelloFresh. We are not just offering HelloFresh as a core offering. There's a bunch of other brands that we have. And probably very few people here also know that HelloFresh is actually a German company, even though the US is our biggest market. So we are very active here. And as you can see, there's a bunch of other brands that we also have that we are operating here, including Factor, for instance, which is pretty big here as well for ready to eat. But also some other offerings like pet food, if that's something that you might be interested in. Just so you get an idea about the numbers and the scale that we are operating in, last year we shipped almost 1 billion meals worldwide. And if you combine that with the total number of 20,000 employees that we have worldwide, that gives you a rough idea in terms of the scale that we are operating in. We have a petabyte large data lake. We have various different tooling that we are using on top of that. But yeah, let's dive right into that aspect. So data engineering at HelloFresh. Data engineering usually breaks down still into two large categories in that sense. There's the batch processing on one side. There's the stream processing, or more event-driven real-time side of things. And that is still how it breaks down for us as of today. When we start on the batch side, there's a bunch of different sources of where we are getting our data from. We have a company-wide Kafka-based event bus. We get a bunch of data from backend databases, for instance, of the different services that we are operating. We still run a lot of processes on Google Sheets. So that's a lot of data that we're also getting from there. And of course, there's also a couple of manual sources that people are directly uploading, sometimes even directly interacting with some of our partners. So first thing is you understand the sources, and then you start processing them, right? You start setting up the infrastructure, you start building your data pipelines, you start setting up your orchestration. The core setup that we have is, on the one hand side, we are almost exclusively AWS-based. So most of our data sits in S3 when it comes to the analytical plane. And we use a bunch of AWS native tooling as well when it comes to that processing. Specifically, Spark on EMR is something that we are very actively using for data pipelines. pipelining. We even wrote an in-house framework that allows people to simplify how they are writing data pipelines, and that automates a lot of the infrastructure creation for them. So using that, using Airflow largely for orchestration, writing the data back into S3, and then really getting into the part of then using that data to actually create value, where we have like a little bit of a split approach. We do have Snowflake on the one hand side as a data warehouse. You can move the data into that. We also apply data vault modeling in there that allows you to give like a bit more structure, specifically applied to like the, let's say, top 100 metrics that are really being used for decision-making company-wide. So that is very actively practiced on that side. But when it comes to data activation, that's also where we really leverage Databricks as well. We use serverless SQL as like the main distributed SQL engine with like about 1,200 users on a monthly basis. And but we also have like various other offerings from Databricks that we are leveraging there, specifically when it comes to the machine learning space, where we have like a bunch of data science teams that are also looking into that and leveraging those features. And then we use Tableau on top of that when it comes to the visualization, so that you get a bit of an understanding how the whole stack looks like end to end. When it comes to the streaming side of things, we use Flink. When it comes as like a stream processor, for the one aspect, of course, directly interacting also with the data that we have in Kafka. So like really reading data from there, doing some modification on the streaming data itself, writing it back to Kafka so that other services can also interact with that. But we are also leveraging Flink when it comes to operational monitoring. So some information that is then directly going into some Postgres databases that are then being leveraged for visualization, specifically monitoring and alerting on the operational side, where we are largely leveraging Grafana for that entire setup. But of course, also that is used then for further analytics. So like we are entering exactly the same space that we just previously showed on the slide to cover that aspect. What are some of the challenges that we currently have with that? Well, on the one hand side, if you look at the big picture, we have now 4 different engines that are like interacting with our data on a regular basis, and permission management across these different engines is quite complicated, right? At the same time, we also have a lot of different touch points with the data on S3 itself, and data management on S3 prefix level is an absolute pain. And that goes one level further as well. When you look at the data integrity of the data that you have on S3, it's an absolute nightmare, right? Like trying to operate on these things on file level, you engage all these challenges like corrupted files, unintended overrides, like something like a small file problem. That's something that you're always encountering on that side. And that's specifically what drove us into the direction of looking into table formats, right? First things first, table formats in general, there's like a bunch of advantages, of course, when you look at the different things, Delta Lake, Iceberg, Hoodie. Asset transactionality was super important for us, but also getting some of the features like time travel or the data versioning in that sense to get rid of these data integrity nightmares that we had up until now. Schema evolution, but also schema enforcement in that sense is something that was very important for us, and generally having that level of metadata management so that we could process the data in like much more integral way. What were the HelloFresh specific considerations that went into that? Well, on the one hand side, we were really looking forward for this engine interoperability, like of the data engineering landscape that we just showed before, right? But we were also really looking towards having a cross-engine REST catalog that would be supported by all the engines, so that we have like a single point of entry where we are actually maintaining our metadata so that it can be leveraged across the board. But then also looking at some of the industry dynamics, right? Like we already had some tables in Delta format as well, which was usually data that was natively created on the Databricks side. But with the acquisition of Tabular last year, there was also a big push on our side where we saw, okay, Databricks is doubling down on Iceberg, and a bunch of the other vendors that we've been working with have already been very actively working with Iceberg before. So it became like a huge push into that direction for us. And on the one hand side, that also resulted in the situation that we saw that Also for the data warehousing aspect, working with external tables in Iceberg format, we saw that there were minimal performance penalties. Like was really almost as good as working with like internal tables in that respective setup. And then also seeing that the Unity catalog integration with Uniform was pushed a lot more forward, that really brought us to the point that we said like, okay, maybe we don't even have to have like this clear separation between Delta and Iceberg because they are getting closer and closer together. If you've seen the Iceberg 3.0 announcement that just like launched 1 or 2 weeks ago, it's really showcasing that it's more and more moving into that direction, right? And that in combination with like the wide community support that we have on that really like pushed us towards the decision to go all in towards Iceberg. There are still some format-specific features, like specifically hidden partitioning. Like after the 3.0 release, I think like now that's probably the last big thing that is really still pointing on that side. But those are the last couple of things why we really wanted to move into that direction. And with that, let's take a deep dive into the actual setup of Unity catalog for Apache Iceberg. And for that, I'm handing it over to Adam.
Thank you, Max. So before we see how easy it is to connect Iceberg Unity with our various tools, let's start with a couple of opening notes. So first, we heavily relied on the private preview feature. This was enabled for us at the beginning of the year. We received a couple of updates. It's still in private preview. Hopefully, it will be released quite soon, so everyone can get those features enabled for them. We are also deployed in AWS. We are using single region for our data processing, so this might also matter if you have different cloud provider and different setups. And now we also need to create special permissions on the Databricks level. First is external data access. This needs to be enabled on the whole metastore. Without this, it's not going to work. And also each Unity catalog, which requires to be accessible by the external tools, needs to have external use schema enabled. And it's quite important to note because initially like the troubleshooting was not that easy. Like we have got all the same setup for the tools, why one catalog works and another doesn't work. So those settings are quite important to get in place. And also all the examples I'm going to show, I added them to my private GitHub repository, acomisarek/Unity catalog examples. So feel free to copy, use them, however you want, take inspirations. Also, let's cover how we sort of govern access to our tables and how we create even maybe the tables. So although we are AWS house, we use Microsoft Entra ID, previously known as Azure Active Directory, for our user identity management and the group creation. So to simplify this for the users, we created like custom modules, Terraform Python, which allows you to easily create new groups in Entra ID. However, the user-to-group management varies often. Sometimes we do manual addition to the groups. In some other repositories, we are using Terraform. And of course, after that, we use scheme functionality to sync all of our users and groups to the Databricks. So it allows us to attach permissions to the groups for appropriate assets. So of course, we don't want to rely on the access being granted directly to the users or something like that. So for ease of management that we are using the group level permissions. And what's important is also something we spend quite a bit of time troubleshooting is that whenever you create the groups manually, for example, for testing purposes, those groups, they need to be like account level in Databricks and not the workspace level. Otherwise, the Unity catalog and that's not going to work appropriately. We also hit some problems with Terraform provider, as this is private preview feature. There is no support for Iceberg as of now. I'm also not sure if the Terraform is the best tool to create the tables, but because there was not a clear and immediate solution for us, we rely for now on like ad hoc table creation. So the users most likely are creating a tables just inside the processing scripts. So with that out of the window, let's start with the beginning of the journey, Flink and our streaming data. So Flink has got the idea of the catalog, and you can create a new catalog with a couple of configuration parameters. So we need to configure that our REST catalog is of type Iceberg. They also required you to provide catalog type in our instance REST. And we need to specify the URI, which is our Unity URL. Most likely it will be always the same. The only difference is like you need to provide your workspace. And after that, it's the common URL for everyone. And you need to authenticate appropriately to the catalog. So here we are using on behalf of token for the service principal. When we were initially designing this and working on this, this was the only supported way of authenticating. I think also now OAuth 2 is supported. But for now, we are still using the token-based authentication. So essentially, this service principal needs to have access to our catalog, which is configured as a warehouse parameter. So with that in place, we can then have this super simple Flink application, which is querying source data. So for example, it can be our Kafka topic. We provide some transformation on our data coming from Kafka. In this instance, we use tumble window. We group by 5 minutes. We are interested in number of items, maybe some value of our order metrics. And with this process, we can now invoke insert into statement, REST catalog, which is our local catalog name, which we have just created, and then schema name and table name, which are now Unity catalog resources. With this simple setup, we have got now continuously inserted values into our Unity table every 5 minutes. But now let's assume we want to build on top of this batch processing. So we are interested in aggregating every day, overnight. So we are using Spark for it. From Spark perspective, the configuration is slightly different. You essentially need to configure specific Spark settings. And the important setting here is the Spark SQL catalog. And after the dot, we also have got the local catalog name. So how we are going to refer to that catalog in our Spark application. So in this instance, we have got Unity. And the first parameter is essentially Java implementing the Iceberg catalog, which is what comes from the appropriate dependencies. So we have got org, Apache Iceberg, Spark, and Spark catalog. Again, type is REST. Of course, Iceberg supports different versions of catalog, but we are interested in REST here. And the same parameters as with Flink. URI, warehouse, and token. Nothing different here. 2 points to note. I also configured extensions. Extensions essentially allow you to enhance your Spark SQL with additional like Iceberg functions. So for example, for metadata management and things like that. And also what I'm going to showcase later, we have got the catalog.spark catalog, which is like default catalog for Spark, still configured for Delta. And this allows us to essentially use 2 catalogs at the same time and ensure that our older jobs, they still work as expected and they can still query all the data as expected without any interruptions. So with this configured, we can now invoke our Spark SQL statement, insert into appropriate Unity table. And again, Unity is our configured local Spark table, Spark catalog. And then order metrics and order statistics daily are essentially the resources which we created in the Unity catalog. And it's just a simple example that we are also actually selecting from another table which was prepared by Flink. So of course, based on the appropriate permissions, depending on how you configure your users, that user which is invoking the Spark process might need to have the right to appropriate table and read to another table. And with this in place, we can, as you can imagine, query this quite easily on the Databricks site without any extra settings. So of course, assuming that I, as a user who was invoking this query, can access order statistics daily, I have got read permissions, I can see the results of my transformations, and also I clearly see in the Databricks Unity Catalog UI that this table is managed, and the most important thing, it's of type Iceberg. So Max mentioned that we had got a lot of issue with the file permission. So why this works? And I haven't mentioned anything about giving access to file. I mentioned only giving access to the table. And it works thanks for this idea called credential vending. So this is probably where is the biggest difference between various cloud providers. As we are AWS house, I'm going to explain this on AWS example. So in order to start, we need to cover 2 Databricks resources and 1 AWS. So from the Databricks perspective, we have got something which is called external location. An external location, you can attach this to like Metastore or maybe catalog or maybe schema, and it's essentially location where the Iceberg tables will be stored in S3 under some kind of prefix. And it also has got information what credential will be used for this particular external location. And the credential is like a key. It's information what role Databricks will need to use. And the role is AWS resource, is some kind of special identity which doesn't have a password, and it's used because it can be like impersonated by either real users or by machines, and that role will have access to appropriate data location. So essentially, to summarize, the role is like 2 things. It is information who can assume that role, who can impersonate that role, assume is term AWS uses, and what resources that role can read. So with this in mind, let's see how our external tools can use this to get access to data without actually having explicit access to data, physical data granted. So there is a special endpoint called temporary table credentials. And that endpoint will return you appropriate credentials for that table. So how it works is that the Databricks obviously knows what is the table location and what are credentials for that table. And it will check if you have got appropriate permissions as a user to that table. And it will invoke assume role on the special AWS service called AWS Security Token Service. And what's important here, this assume role operation uses the idea of session policy. And the session policy is essentially a mechanism to lower down the permissions you can do. And you can imagine this is required because our role has got permissions to read and write data. Maybe it has got permissions to access other tables. So during this assume role with the session policy process, Databricks requests new credentials, but only, for example, for read access. And then those credentials are returned to our Spark application, and you can safely access data. You won't be able to access anything else. You will only be able to access files for this particular table. And this is great. This is something you can also test manually. This is just REST A point, which you can invoke from the command line. It's quite great for testing and ensuring everything works as expected. So that covers our LRE journey. Let's see also how we federate our catalog. So this is important for us from 2 angles. First is going to be Snowflake, and another is going to be our legacy file, our legacy catalog, which we use AWS Glue. So let's start with the Snowflake. Snowflake is quite similar to what we had in Flink. It uses the same idea. There is a special resource called catalog integration, and we need to specify catalog source being Iceberg REST. We need to specify table format being Iceberg. A bit weird specifying the same thing twice, but it needs to be done. Catalog URI is something we already know. And the new parameter, sort of, is catalog namespace, which is our schema name. So Snowflake sort of links your catalog integration directly with the schema. And then to continue our configuration, we need to specify REST config, which is essentially warehouse, our catalog name. And this access delegation mode is something which I have just explained. Vended credential will allow Snowflake to access physically the data without going through the loops of configuring access from the Snowflake itself. And then we need to finish with the REST authentication. Again, we set this up using on behalf of token. I'm pretty sure it supports OAuth 2 at this moment as well. And you just need to flick the flag. You cannot see this, I think, at the bottom, but there is enabled through as well. And that's it. With this in place, you can query the data, almost. You can query the data. There's this extra step needed on the Snowflake side where you need to create a table, create Iceberg table. But of course, it doesn't copy any data. It's just some kind of metadata information for Snowflake that the table you will create on the on the Snowflake side is linked from the catalog you configured, and the table name in that catalog is, for example, in this instance, order statistics. And Snowflake sort of like refreshes metadata periodically, so it doesn't actually go and query the Iceberg table completely. So this auto refresh is also required. Otherwise, you might need to specify some kind of manual refresh, which is not ideal. And with this in place now, we can finally query our order statistics table, and it also gives us appropriate results. Again, everything without touching the physical file authentication, but only one thing which you had to configure is this on behalf of token for Snowflake having appropriate permission to the schema and to the table. Okay, so now let's address our big elephant in the room, our legacy Hive, and the options we tried to federate this catalog. So our main legacy catalog is AWS Glue data catalog, and we have got over 46,000 tables there at the moment of speaking. We tried AWS Glue foreign catalog integration with the Unity catalog. It works, but only for the read-only access tables. Like you cannot write when you use the foreign catalog integration. So it's not ideal for all the use cases. So we still sort of need to rely on this, that you can configure the tools to support multiple catalogs and, for example, still rely on this Hive unless you can really go out of it. And for us, really problematic are quite old jobs, which are writing directly to Glue. And what I mean here, it's some jobs can even directly invoke Glue API to create the tables, or even they would dump raw Parquet files or even JSON or CSV files, and people would have like crawlers to scan the physical files to just create tables on top of them. So for us, it's quite a big journey to get rid of all of the use cases and help our users to build this better with the Unity and more modern table formats. So let's summarize this on the picture. So we have got our external tools, Flink and Spark, and they would be interested in both Iceberg catalog and AWS Glue data catalog. So adding a couple of like sort of interaction points, writing read to Iceberg, no problems. We still need to rely on writing Parquet JSON assets. Ideally, we would like to avoid write, but probably for some time it will be inevitable. So on the external tools, it's actually not that difficult. But when we start looking into Databricks, it comes up a bit more complicated. So we need to add those two ideas into the picture. We need to add our federated catalog, and we need to add our legacy Hive metastore integration. So they work slightly, there is a subtle difference. Federated catalog sort of like copies the catalog and crawl our data catalog on the AWS side. However, the legacy Hive metastore is just like sort of permanent link. But the permissions are completely different. Like for federated catalog, you can already get some benefits of the Unity, which you don't have when you use legacy Hive metastore integration option. And when we start adding our compute, an important point to notice that we are predominantly using on the data side SQL Warehouse as the read workloads for our analytics engineers. And we have got a bunch of compute clusters where data engineering teams would create or update new assets. So adding to picture the interactions from the SQL Warehouse, it's actually quite easy. We don't have many issues with that. You can read Iceberg directly. You can read legacy tables, assuming that all the permissions are in place. That works as expected. However, the write workloads are a bit more problematic. So first at the bottom, I added even like red arrow going to this legacy Hive metastore. With the Unity catalog-enabled workspace, we have got some permission issues. There are existing workarounds, but all it means that the migration path is not that easy for us. The yellow line to write Iceberg tables was yellow a couple weeks ago, but because it didn't work as expected. But now in the latest updates, it actually works, which I'm going to cover right now in the limitations and configuration section. So a bit of that will be a bit of updated. This is actually super quickly moving space, and we were working on the slides and preparing that. Things didn't work, which they changed in the meantime. So let's take a look. So from the Snowflake perspective, we would like to close this loop and also enable writing into our Iceberg tables. They didn't support that initially. They have now in like private preview, which I managed to test like 2 weeks ago or a week ago even. It works, but it doesn't support this credential vending idea. So it's not that simple as we would like yet. So we are keeping an eye on this as well. And also some important features are only available in preview from the Snowflake perspective as well. So you cannot rely on properly partitioned Iceberg tables. Initially, they were using like their own algorithm, which made Iceberg files not properly readable by the other tools, which was not ideal. From the Databricks perspective, writing to Iceberg table was not possible, either via compute or SQL warehouses. This has changed at the beginning of May, and it's now possible to write to Iceberg tables from compute, but not from SQL warehouse, at least as I tested this 2 weeks ago. This like reading Iceberg tables also was converting underlying tables to Delta. Maybe it doesn't matter for the end users, but when we were like implementing that, it mattered because that conversion required modify permissions for the user calling this operation. So it didn't work for us because our read workloads actually had to have modify permissions on the table. But again, this is actually now fixed from the beginning of May, so we were so happy to see it. Then sort of the last couple of things, troubleshooting of all of this was sometimes quite difficult, as I mentioned, like missing some of the setting ended up with like S3 related errors. I think some of them were also improved in the last weeks or month, but maybe there is like odd, not properly handled scenario there and there. And as you could expect, because it's like quite a new way and approach of doing things, the information on the internet is quite scarce, and AI is not doing great to help you and suggest proper solutions. It's hallucinating quite a lot. And from the asset creation perspective, this is something we try again to find how to work best with that. Databricks supports Terraform liquid based on Flyleaf, although still not for Iceberg unless maybe it changed a week or 2 weeks ago. We are not using liquid based or Flyleaf, so maybe we will need to end up writing some of our custom scripts, but this is something for us to also consider going forward. And for our users, like this whole migration, it's not migration only to Unity, but also Iceberg. As I mentioned, we have got a lot of quite legacy use cases, and trying to get everyone on board it will be quite a big journey for us. So with that, I would like to hand over to Max for the wrap-up section.
Yes, exactly. Thanks a lot, Adam, for like walking us through all those technical details. So let's just like summarize what we were taking a look at throughout the session of today. So first things first, Iceberg with Unity works quite well for us because it actually integrates quite well with the entire tech landscape that we have at HelloFresh, right? And specifically also having the Unity catalog integration with Uniform, thus also supporting Iceberg and Delta, as Adam just mentioned behind the scenes, is something that works quite well for us because of some of the legacy constraints that we still have on that. Just recapping, like that there's almost no performance penalty also for the data warehousing use cases that we have. So that was, of course, like a pretty important point to us. But one aspect that I really have to highlight here once more is that like this wide community support that the topics have right now, and that there's really very active development from all the vendors that are like involved into the pictures that we showed earlier today, is really allowing us to make like huge progress in this space, right? Like a lot of these cases that Adam even mentioned that didn't work for us originally, and even like within a couple of months have already been addressed and fixed, that only showcases like how much of an importance that is to all the companies that are involved in that space. And that gives us also a lot more confidence that this is the right choice and we are moving into the right direction here. Some of the learnings, integration is very much possible across the entire ecosystem, but it's still quite techy, let's say, right? So there's still like quite some limitations that we need to go through. There's like a bunch of things that you need to figure out, sometimes with hacky workarounds, sometimes also by pushing the vendors a bit more to address some of those shortcomings, which again, they are very happily able to oblige. But generally speaking, it's a very fast moving space, right? Like, so some of the core concepts that were still true 6 months ago have been like completely addressed already like throughout the last couple of months. So it's great to see that there's like a huge amount of innovation that is continuously happening and it's like spreading more and more also across the industry. Yeah, as I already mentioned, some of the issues from 3 months ago have already been resolved by now, but there's still a lot of moving pieces to really fully productionize this at scale, right? And when I'm looking at the next steps here, also for us, this is only the beginning, right? We have end-to-end production setups now that are like up and running. We have everything throughout the entire tooling landscape that we have here, but we still need to scale this across the entire organization, right? So there's still like a lot of things where we now need to migrate away from some of that legacy so that we can fully be committed to the end-to-end setup that we have now showcased to you folks today. We are very closely working with the Unity catalog team as well as with the Iceberg teams to drive this forward. And this also really helps us to engage in the follow-up conversations. And that's also something that I can very much encourage you folks. If you have the needs, if there's something that you want to double down on, if there's something where you just want to discuss like the potential options, reach out to the community, become part of the community, reach out to us. We're very happy also to have some follow-up conversations on that. And with that, there's only one thing to do, and that is to say thank you.